With its advantages in low power consumption and self-organizing networks, the ZigBee protocol has a wide range of application scenarios in the field of the Internet of Things. It has advantages that cannot be ignored in smart homes and smart light control. The ZigBee protocol stack is generally divided into 5 layers, namely physical layer, MAC layer, network layer, NWK, APS layer and application, app. Each layer can receive data and event notifications from the lower layer and provide API for the upper layer to call it. Service. This hierarchical structure ensures clear responsibilities and modular design among various parts, making the entire communication process efficient and orderly. The specific functions of each layer are as follows. The physical layer is mainly responsible for modulating the data packets transmitted by the MAC layer into wireless signals and sending them out, as well as receiving specific wireless signals and restoring them into data packets and transmitting them to the MAC layer for the next step when the MAC layer needs data. For data processing, the physical layer also stipulates that the frequency bands that may be used for wireless transmission are 868, European frequency band, 915, American frequency band, and the 2.4G global frequency band. In China, the physical layer stipulates that the 2.4G frequency band uses OQPSK modulation method, 915 and 868 use BPSK modulation technology. OQPSK modulation has good anti-interference ability and high communication rate. The MAC layer mainly has 3 functions. First, the MAC layer is responsible for receiving data from the network layer and encapsulating it into a certain format of data packets, including frame header, address, control field, payload and verification, etc., and sending it to the next layer. Secondly, the MAC layer is responsible for data authentication, encryption and data confirmation to ensure that the transmitted data is reliable and will not be intercepted or tampered with by other unauthorized devices. In addition, the MAC layer is also responsible for establishing connections between nodes, coordinators, and routing and performing necessary identity verification and secret key exchange, management and identification of device long and short addresses and the use of broadcast and multicast addresses. Finally, the MAC layer is also responsible for resolving network data conflicts. It generally uses the CSMA/CA algorithm, that is, it detects whether the channel is idle before sending data. If the channel is idle, the data will be sent out. Otherwise, it will be randomly delayed for a period of time before trying to send again. When the MAC layer receives the data transmitted by the upper layer, it will encapsulate the data in formats such as frame header and destination address according to the data content and pass it to the physical layer for sending. When receiving the physical layer data packet, MAC will unpack and send it to the upper layer for processing. The network layer in the ZigBee protocol stack is mainly responsible for handling the communication of node components and maintaining the structure and functions of the entire network to ensure that data can be routed and transmitted correctly in the network. It mainly has the following functions. 1. Allows the establishment of new ZigBee networks and assign a PANID, network identifier, and network address to the new node and address mapping to determine the destination address. 2. Manage the role status of the device and allow nodes to switch between coordinators, routers, and terminals. 3. Responsible for storing the routing table and forwarding data to the target node according to the routing table. 4. Provide fault detection and network recovery mechanisms, such as monitoring node activities, processing network fault reports, etc. When the network layer receives data from the upper layer, it will further process the data and select an appropriate routing path, and then transmit the processed data to the MAC layer for further processing and transmission. The APS layer connects underlying network services and upper layer applications. The main function of the APS layer is to provide end-to-end data transmission, so that the application layer does not need to pay attention to routing and physical layer details. It establishes a direct connected virtual channel between the source node and the destination node, and processes data from the lower network layer, notifications and events, and convert them into a form that can be directly used by the application layer, while also passing requests and instructions from the application layer to the network layer. The application layer defines the device behavior in data exchange format in specific application scenarios to realize specific functions of the device. By interacting with the APS layer, it requests to send data or responds to the received data to realize interconnection and data between smart devices exchange.